Well, we can find center of mass and moments of inertia of a solid region. Similar, or at least the same principles apply here as moments of lamina about coordinate axes, but now the moment is the mass times the distance from the rotational fulcrum, but in that case it might be the xy plane, the xz plane, or the yz plane for a solid. So given a density function, rho xyz of a region, then the mass can be found by the triple integral, of course the triple integral with density times our volume element. But to calculate the moment about the yz plane, remember x is the distance of a point from the yz plane, so it just needs an x in the integrand. Similarly, a moment about the xz plane needs a y integrand, and a moment about the xy plane needs a z in the integrand. So that covers our story on moments of inertia. I might mention at this point that to find the centers of mass, that's just going to be the x bar is the moment about the yz plane over the mass, y bar is a moment about the xz plane over the mass, and z bar is a moment about the xy plane over the mass. So moments of inertia are the second moments, sometimes taken about the coordinate axes, not about the coordinate planes. And the square of the distance from the point of the axis is used. So the square of the distance from xyz to the x-axis, using the distance formula, would be the distance would be the square root of x minus x plus y minus squared plus y minus 0 squared plus z minus 0 squared. So it would be the square root of y squared plus z squared, but I'm going to square that distance anyway, so it's just y squared plus z squared, which appears in the formula for the moment of inertia about the x-axis. Here it is. See the y squared plus z squared showing up there, times the density times the volume element. Similarly, the moment of inertia about the y-axis has to have an x squared plus z squared in it, times the density times the volume element, and similarly, the moment about the z-axis has an x squared plus y squared in it, times the density function times the volume element.